So we're going to be talking about stationary points, and these guys have a few different names, like turning points, vortex, maxima, or minima. What a stationary point is like is you may have a graph that looks something like this, which is a parabola, and you may have a graph that maybe looks something like this, which is a cubic graph, and then you may have other graphs. But stationary points are basically these top points. So these top points on these curves, these top points. And what's special about these turning points or these stationary points or these vertices or maximas and minimas is basically that the gradient is basically zero at these stationary points. And how we can use that is, well, basically in the context of differentiation, know that our gradient is basically equals to dy by dx, dy by dx. So what we can do is we can basically say that, okay, our gradient is equal to zero. And then we can basically use this idea to find out the coordinates of a stationary point. The way you would do that is by basically, you would have an equation for the gradient, right? So let's say you have a gradient for the equation, which is dy by dx is equal to, let's say, x squared. This is your equation. And so one thing you can sort of do is basically you can say if you want to find the coordinates, you want to find the coordinates of the stationary point, then what you can do is you basically know that the gradient or the dy by dx is basically equal to zero at the stationary point. So you can put this thing equal to zero, right? And then this thing would basically be zero. And then you can solve it for x. And when you solve it, your x is basically going to be zero. So that just basically means that if you have a curve or a graph, then it has a stationary point when x is equal to zero. And then what you could do is basically, if you need the y coordinate, what you would do is, wait, I'm going to erase this. If you want to find the y coordinate, then you will basically have some equation for the curve itself. Let's say it's y is equal to something, something, something. So if you want to find that y coordinate of the stationary point, then you already know the x coordinate of the stationary point. So just go and put the x coordinate into the equation of the curve, and you will basically get the y coordinate as well. And then whatever it is, you can sort of write it over here, and then you'll have find your x and y coordinates for the stationary point. So this is a really useful idea if we know that the gradient at the stationary point is equal to zero. And let's just do an example over here. I'm going to erase this stuff over here. Just going to erase this stuff. And what I am going to do is I'm going to imagine a curve over here. So let's say I have a curve y equals 3x squared plus 2x. And what I'm going to do is I'm going to find out, okay, so I don't know what this curve looks like. I know it's going to be a parabola. Why do I know that? Well, because it's basically a quadratic curve. It's a quadratic equation. It has the x squared. So it's obviously going to be a quadratic curve. And since this 3 is positive, I know that it's going to be a parabola that's like this. It's going to be a downward facing parabola. Okay, if this sign was negative, then the curve would basically have been like this. This is not even from differentiation. This is from quadratics. So I hope you guys are already on your A game with quadratics. Okay, so we have this curve over here. Now I'm trying to find the stationary point of this curve. I'm trying to find the coordinates of the stationary point. So since I know it's a parabola due to that square, and since I know that this 3 has a positive sign, so it's going to be sort of like this, a downward facing parabola. So I know that it's going to be a curve, and I'm basically what I'm trying to do is I have a top point up there, and I'm trying to find the coordinates. So I would first find the x coordinate, and then I would basically go ahead and find the y coordinate. So basically, if you imagine axes over here like so, then basically that point will have some x coordinate and some y coordinate. That's what I'm trying to find out. So the way I do that is basically I basically differentiate my equation. So I'm going to differentiate this. Now I'm going to do this quickly. I'm not going to go through each of the single process, but you guys can do that if you want to. I'm just going to get straight to the answer here. It's going to be 6x plus 2. That's going to be the differentiation. And see, I know this thing that the gradient at the stationary point is equal to 0. So when I chuck that 0 in here, I basically get 0 is equal to 6x plus 2. And now when I solve for this x over here, what I'm going to get is I'm basically going to get the x coordinate of that stationary point. So basically, this is 6x. I send this 2 over there, so it becomes a minus 2. And I basically have x. The 6 can go over there and divide, so I'm basically left with negative 2 over 6, which is going to simplify to 1 by 3. So it's going to be negative 1 by 3. So this is the x coordinate of the stationary point. Now if I want to find the y coordinate, I can just basically go chuck this x in here and in there, and I'm going to get that y coordinate as well. And so therefore I can state that the stationary point has this x coordinate and this y coordinate. So again, what I'm doing over here is simply I know that the turning point has the turning point or a stationary point or the vertex or the maxima or minima. They basically have sort of this stationary point which has a gradient of 0. And so what I can do is I can chuck that 0 in the differentiation equation, and I can solve it for x. And then once I get the x coordinate, I can go and put that back in the curve equation, this guy, and get that y coordinate as well. And then at the end, I can sort of state that this is the x coordinate for the stationary point, this is the y coordinate for the stationary point. Now, one thing that you may come across is that over here, this curve was y equals 3x squared plus 2x, and we sort of knew that our stationary point is going to be on top of this hill, right over here. And the way we knew that is, well, because we know that when we have a square, we have a parabola, so it can be either this parabola or that parabola. And then the coefficient of x squared, so this is x squared, the coefficient is 3. If it's positive, then we basically have a downward facing parabola. If we have a minus, we basically have an upward facing parabola. So we just sort of knew that this thing, if this stationary point was on the top of a hill or on the bottom of a hill, because we used this knowledge from quadratics over here. Now let's say if you have another equation, which is y equals, let's say 3x to the power 3 plus 5x plus 2. Let's say you have some equation like this, then now you don't know if the stationary point that you're going to find, is it going to be sort of an uphill? Is it sort of going to be a downhill? Why do you not know that? Well, because you don't have the knowledge for a cubic equation, right? This has x to the power 3. And then in the same way, I can give you another equation. Let's say y equals 4x raised to the power 5 plus 6x minus 1. You can't really know what your stationary point is going to be in this case. You don't know if it's going to be on the top of a hill or on the bottom of a hill, or in other words, is it going to be a maxima? Is it going to be a maxima, or is it going to be a minima? So you can't just guess that, right? Over here, it was easy to guess because you could sort of just imagine what the graph will look like based on the knowledge of quadratics. But with graphs that you have not, with equations and graphs that you've not studied, it's harder to do that. So you may find the x and y coordinates of the stationary point. You can still find the x and y coordinates, but you won't know if those coordinates are for a maxima or a minima, because both of those are stationary points. Both of those are sort of on the top of these sort of humps. So they're both stationary points, but you have to sort of do something else to confirm if what you have is a maxima or a minima. So finding the coordinates is not just enough. You sort of also need to know the nature of the stationary point. Is it a hill? Is it the top of a hill? Top of the hill? Or is it the bottom of a valley? Is it the bottom of a valley? So to understand that nature, we basically use something which we call the double derivative, and that's what we're going to do in the next video.